Hey everyone, today we're gonna look at how to install iamid Community Edition on AWS, on your AWS. iamid Community Edition is a free version of iamid Enterprise Data Lakehouse platform, which is completely free regardless of how many users do you have, the data size, the computation, the compute size. It's completely free and free forever, and you get with that managed data lakehouse, which is built on Apache Iceberg and Spark, which is extremely scalable from terabytes to petabytes. No lock-in because it's built on open core on Apache Iceberg, Apache Spark. Data is stored on your account, on your S3 in Parquet format, which is also open standard. Like everything is open. iamid provides easy to use infrastructure environment for you. It's cost efficient. Of course, you don't pay anything for iamid. It's completely free, the community edition. You only pay to your AWS resources that you use. And there is an additional benefit that you can use spot instances, which is 3 to 4 times cheaper than on-demand instances. And there is also reserved instances. Your company might be using that, or your company have AWS credits, so then it will be much cheaper than using other vendors already managed solution and paying to them the AWS cost, usually on-demand price plus the margin for them. iamid runs on all the clouds and on-premise environments, and again, it's free. Let's move to installation. For installation takes around 20-25 minutes, maybe max 30 minutes. Most of it takes running Terraform script. Terraform is creating AWS infrastructure like VPC, like EKS cluster, S3 bucket for lakehouse data storage, and roles for EKS to get access to EKS compute, get access to these S3 buckets. And then once the AWS infrastructure is ready, then you deploy iamid platform using Helm, which takes about 5 minutes in the first installation. For later upgrades, it should take less than a minute. You need the AWS account, AWS CLI, Terraform CLI. Don't worry about if you don't know Terraform. You don't need to really know Terraform. You just need to run a bunch of commands. But if you want to learn, it's extremely easy. kubectl and Helm to deploy Helm Kubernetes resources, Helm resources. First, we need to download this, clone this repository. You just copy this. This repository mainly carries this Helm values. For default installation, we won't change anything from here, but if you want to customize, you can check this values before you go with the installation. Let me do clone, change. Yeah, now I'm in the directory. Okay, there are some additional settings. You can have a look here. And then the first step, let's move to Terraform directory, run init, which is downloading all the modules. It's kind of npm install for front-end framework, or Maven, not install, maybe Maven compile, not compile. I don't know for the Maven, but it's just pulling out the modules that Terraform script use. Before before we apply, we need to update the values accordingly. It should be very simple. Let's do, I use IntelliJ IDEA as my default notebook. Yeah, we need to just check these values, and specifically we should update the values region, which AWS region that you wanna deploy. You wanna give a cluster name and S3 bucket name, which should be unique. Let's say as a cluster name, I say Lakehouse Community Edition, or I am at Lakehouse something, and here I say Lakehouse A1. I hope this is a unique, because AWS has, if anyone's in the world created this bucket, then it won't allow to us to create this bucket. And that should be all. The version is the latest version. We can check that version. Yes, this is the Terraform module. Yeah, version match. Here's the installation. Here's the same example here as well, and it's open source. You can have a look at the GitHub, which resources it creates. So let's go back to apply. Let's do apply in the Terraform folder. Again, as we mentioned, it will take about 15-20 minutes, depending on how AWS will respond. By the way, it first shows me the plan and which resources it will create. It shows all the resources. We say yes. We can have a look all these resources beforehand. You make a yes. Now it creates all these resources, and then once it's done, we'll just update our kubeconfig and continue with the Helm installation. I am going to pause here, and then I'll get back once it's done. Okay, I'm back after 15 minutes. This AWS Terraform installation is done, and as a next step, we need to update our kubeconfig. So in order to access there, so region is US East 1 and -- name. Let's see, what was the name? The name was Lakehouse CA. This is the cluster name, and also we can see from the output, yes, this is the name. Okay, done. KC, this is the alias for kubectl in my own environment. Let's see, current context. Yes, we are pointing to the newly created EKS cluster. Nodes should be a single node there. And let's see what's next. The next is preparing metadata database. So here we use MySQL from Bitnami, and for IAMIT stores all the metadata of your data, metadata of the UI side elements, everything in that database. You can use, this is not production ready one, it's just for test purposes. For production deployment, you can use an RDS instances, or you can have your own deployment of MySQL to the Kubernetes that is production ready. So for this demo, it's fine to have a test environment. So you need to add bitnami repository and update your repository. I've done these steps. I'm not going to do this again. And now everything regarding IAM8 will be installed on IAM8 system namespace, which is already created by the Terraform. It should be there. Let's check. Get ns. Yes, IAM8 system namespace is already there. Yeah, let's copy this. It reads data from MySQL values.yaml. Should be. No, this is a Terraform. I need to go out. Yeah, this is Terraform plus everything else. We are running from here. For MySQL values, you can check these values. I'm not touching anything. This is already good enough for test environments. I can say even it might be ready for production environment as well. So we just need to, we're not going to customize anything. We'll just run this command, and this takes about a minute to bring up MySQL. We can check with this command. Yeah, continuous creating. We'll wait a minute and then continue from. Yes, MySQL is up and running and ready. It takes around 53 seconds. Now we have everything ready, and then we can continue with the IAM data plane deployment. For IAM data plane, you need to add this repository and update the Helm repo on your laptop. I've done this. I'm not going to do it again. And we'll do Helm install to this namespace. This is a name. This is the chart name. These are the values. Like values, again, you can see from the clone repository. These are the values. So I'm not going to change anything, but if you bring your own database which has different credentials, you can update those stuff here. We don't need to worry about this password, admin user password, which will be reset on your first login. It's pretty simple. Let's go and grab the commands. Since we are not updating any values, this should be very straightforward. You just copy this and then paste this. Okay, which takes here, and for the first installation it takes about 6 minutes. We'll wait until all the pods are ready, and I'll come back in 5-6 minutes later again. Okay, I'm back after 5 minutes later. There are two useful commands to check if installation is ready. One is seeing all the pods and checking if all of them are running and ready state, which is true in this case. Another useful command is getting Helm releases, which is the installer of these pods. So we see all of them are in ready state. So that means our installation is good. You see here a bunch of pods and enterprise gateway, core, identity, SQL, Keycloak, etc. We'll explain all of them in another video. We'll go in depth of all these components, but for now, today our goal is to do the installation and bring the UI. So in order to access the IAM8, we need to access the Istio, which is an ingress service. So if we do this, it shows the Istio ingress and what external IP Istio ingress it provision the load balancer on the AWS infrastructure automatically when it's installed, and then it gets an external IP. In AWS case, this is a load balancer's DNS. Sometimes it returns IP for Azure or other platforms. But yeah, once we have this, we can access to IAMIT UI. In this case, we haven't configured any TLS settings. That's why it will be HTTP. You can configure additionally a DNS, which is you go to your Route 53 and then add your preferred DNS name, and then point to this DNS using CNAME record. If you want to configure TLS, you just need to then add TLS configuration in Kubernetes and then configure Istio to use that. I'll also add a additional documentation about how you can do that. But for today, let's access to this UI using this one. Let me add this somewhere here. And HTTP, and then let's access to this one. Okay, the username, password, as I mentioned, these are username is admin, password is a temporary admin, and we just need to type those, and it will require us to reset our password, and you provide your own password. And then that's it. Installation is done. Now you can create a lakehouse cluster. You can then let's say this, choosing the smallest instances. You can opt in for Spot, and then the auto suspend will scale down resources automatically when there is no load within 30 minutes or 5 minutes. Create this takes about a minute to get machines from AWS. A single node always being used by the IAMIT platform, but other nodes will be requested from AWS once you create a cluster, and executor nodes will scale down if you don't use those resources. Our lakehouse is running. Then now you can connect from backend application using Python JDBC drivers, DBT, BI applications, and also you can use external SQL editors. And also there is already built-in SQL editor. I will connect from here. I will choose my default database. This is the only lakehouse server that we are running right now. In the first run, I'm expecting a little bit slow response because it's cold. Everything just started, and then from second commands, it should be good enough. So I am doing here, I'm creating this external table that's pointing MySQL, which is running a test MySQL here. Let's create this, and then we can create external MySQL from here directly, which is not storing data in the lakehouse. It's accessing this external MySQL. So since we can query this external MySQL server, we can also easily insert this data to Iceberg table that you are managing in your data lakehouse. This command just query all the tables data. There is no limit, and then create this table with the same column definitions, and then insert all the data from MySQL to this employees table, which is managed by IAMIT Lakehouse. So here's the data. It's very same data, and default, we can see files. Yeah, you can see. Yeah, it's created only a single file, 300,000 records and 2 megabyte. Okay, with this small demo, I want to complete today's installation. We can call it successful installation. And again, feel free to join our Discord community server so you can ask your questions if you get any issue on the installation. And yeah, bye.